Hey Andrew, happy Friday.
Happy Valentine's Day.
That's true.
Yeah.
You got any plans today?
Getting dinner with the wife, and then maybe we'll go see a show or something. What about you?
Nice. Yeah, we're gonna go to a Lego store and buy some
nice.
gifts.
Is that Flatiron?
Flatiron.
Okay,
just down the
nice. It's a
street.
big one, yeah.
But yeah, no big plans, but
Very cool.
should be fun.
Nice. Yeah. So, what's on the agenda for what you want to talk about today?
Well, as always, I think it should be things that we've been dealing with and top of mind for us. And I think one of the things we've been talking a lot about is how we onboard customers and how customers evaluate applications and how do you even have the data in the first place to evaluate, to fine tune all those downstream things that people need to do. Everything starts with data. And I think nobody has enough of it, not in the right format.
It's everybody has some data, but the amount of usable data is so little. So it's like we work with so many of these companies where they have tons and tons of data, and they're like, here's 10 rows of data, here's 50, and so using high quality data for ML is difficult. Even if companies have tons of data, you're working in an environment of scarcity. So
So why don't you maybe explain, maybe level set a little bit on, what kind of data do people need? Why is it difficult to have? Why is this such a common problem that people run into?
Yeah, so I guess this is for evaluations, for RAG apps, for agents. What do you think?
All of the above, but maybe we can start with evals, because that's what everybody's trying to do is like, I have an application, I kind of have it working, but I don't know if it's doing a good job or not. So how do I evaluate it? And that's like when people usually come to us.
Yep. So for evaluation, the data that you need typically is what's going into the system, right? So like, what is that question for a chatbot? What is the input data for unstructured data? What's the question for code gen? What's the input that I'm putting into the system? Then you want the output, realistic output. So something that's already going through your AI application, and this is the output. And then you want the labels of whether this was right or wrong, as well as it's always nice to have this is the ideal answer. With those four things, you can do quite a lot. Now, if you're able to get bits and pieces of more data in the system, even better. For example, let's say you're building a chat app that's like, what is my customer support policy? And it's fetching some data to do the response. Having that data saved is also important.
The context that it's using to answer the question.
The document that was extracted from, the source of where that info came from. And then you're starting off with a really good format of like the properties you want to save for evaluation. And then, the challenge is how do you get enough of it, right?
What does that mean? Like, does it look like tens, dozens, hundreds, thousands? Like, what is the right kind of benchmark for people to think about?
So it's workable through math, which is interesting, which is, for example, if you're like, I want to know if my system's working, and you save 10 of these rows or examples, do you feel comfortable with an exam where it's 10, 10 increments? It's like either you got an 80 or you got a 90 or 100. It's not, there's no 85s, there's no 84s. And then you're like, well, I want a little bit more detail. Then you're looking at, okay, then let's go to, let's say 100. Now I can do 81, 82, 83. But one tricky thing about it is, what if you use some of that data to make your system better? Because if you use that data to make your system better, it's not a great test, right? Where you ideally are testing the system on data it hasn't seen. But if you're using that data to make decisions on how to make it better, then you should ideally separate it out. So then you're also taking that 100 and multiplying it by, let's say, 2. So that you can have 100 so that you can make your system better, and another 100 for testing. And so now you're at about 200, and that's a good starting point. More data is always better, right? Where it doesn't need to, like exams, be 91, 92. It can go from 91.5, 91.4. So let's say one example is a lot of these chatbots, you're grading them not like an exam at school. You're grading them kind of like the SAT, which is you want to know nuances of like, is it good at math? Is it good at the reading side? Is it good at writing?
There are different criteria.
Yeah, I grew up in the 2400 SAT, so it might be different. You in Canada, is there?
We don't have SATs, so
ACTs or yeah.
We just have vibes. You know?
Yeah. Oh, the vibe check.
The vibe check.
Yeah. Good student.
Exactly.
Yeah, looks good. But yeah, and you want kind of to capture the diversity, right? So like you need enough questions to know, are they good at the math part? Right. Are they good at the reading part, the writing? And so
you have a final score that's like your SAT score, which is like, this is how good I am at this. But then you can kind of break that down into different criteria that I might care about. Like you want a student to be good at comprehension and math and a couple of other things. And I guess the same applies to evals of LLM applications.
Completely right. And so now you're looking at a few hundred, right? And so you're working with a few hundred to not only test, but also isolate. Is it good at the retrieval part? Is it good at the generation side? Is it good at combining multiple passages in a document together? Right. Is it better at reasoning? Is it better at numeric values, symbols? You know, is it better at faithfulness or not hallucinating? And so you're trying to capture nuance now. And so the biggest thing around it is, how do you capture all the dimensions and have the test data without in an environment of data scarcity?
Yeah.
And so,
which is like, everybody has data scarcity, right? Like there are never enough labels, there's never enough examples. Yeah. So how do you get past that?
We work with massive companies where you would assume it's like
data
should be plentiful. Tons of data here, tons of data there. It should be so easy, but it's so limited. Yeah. It's so limited because it needs to be in the right format. It needs to be usable. It needs to be high quality, and so you're working with so little. And so a big thing that you and I have been working on is, how do you synthetically create more data from a limited set of data? And that's an interesting problem that pretty much any company that's working on models has already thought about and is investing in techniques. I think this might be one of the more original sides on the evaluation side, which is how do you synthetically augment that data for better evaluations.
So help maybe people understand the ideal world of, like, the promised land of what this would look like if we had perfect synthetic data generation pipelines and all that. Like, how paint the picture of, like, maybe everybody has data scarcity. So what's the ideal world look like? And how do you get there?
So synthetic data is interesting because some part of it feels, with LLMs being so powerful, so easy, where it feels like you can ask the LLM to really create just new data for you. But the biggest challenge with that is these LLMs are notorious at starting to fall into cycles and redundancy, which means you have these LLMs that are starting to repeat itself. And so with any good testing, good exam, right, you can't have 500 questions on algebra and say, this is a really good math student. It's like, what about everything else? Like, there's so many other aspects to it that you need to test. And so you need to create a really diverse set and a good representation of, here's the type of things you'll see. I need to create an exam or an evaluation that really covers the diverse set of use cases. And in order to generate, let's say, an exam for that, it takes a lot of curation and thinking about exactly what are the things I need to test for. How do I make sure that the LLM is creating novel tests and exams to write? And then the hard part at the end is, how do I get the labels for it? Where how do you know if it's right or wrong, right? It's like, I use it too often. I love using the Obama giving Obama meme. Which is like, can you really use data that's used from an LLM to test on the LLM? Is that just like, is it corrupted? It feels like,
or Spider-Man.
It feels like a spy. Two now it's like 3 Spider-Mans. You have LM as a judge. You have the actual app, and now you have synthetic data. It's 3 Spider-Mans all pointing at each other. But if you do it in a very careful way, you can get really high quality synthetic data. And I think it begins with really identifying the synthetic data pipeline, right? And so if you think of it as this pipeline of data flowing through, let's say you start with 10 samples. From these 10 samples, the question is, do I want to create more samples like this, or do I want to create different samples like this? And so from the 10 samples, you can actually map out to other questions, ways that people ask questions, to find similar ways of asking questions of this. So now you're augmenting the amount of questions you have with a data set of other types of questions, right? But then, classic question is, but that's not actually about the same domain, right?
Yeah.
Like you need to still make sure that it's questions like the domain. Well, the really nice thing about LLMs is they're very good at doing this transformation, which is like, if I have a question about, if I have a random question that I would give to an LLM about, what happened in the Civil War and ask questions on it, you can actually map it to other domains, like what happened during the financial crisis and other things. And you can use the LLM to bring its domain expertise, but keep the same structure of questions, because now you can actually create a lot of permutations of ways of asking different questions, a style. We've seen a lot of data where a lot of people ask questions where it's not properly formatted.
Or spelling mistakes.
No punctuation, sentence fragments.
And you want to preserve some of that realism in the sample data you create for synthetically, right?
Exactly, because these systems are working with people. And oftentimes the academia data sets are so perfect that they don't represent how people actually use these systems. Like, I think the last query I put into ChatGPT was like, it was Python function need to get PDF data this format split into this. It was like kind of like a caveman writing it, but like it's these models are so lenient that I almost want to get into this, where I don't want to write everything. I just want to put the quick bullet points and allow it to write. And if this is the behavior people are using, we need to create test data that mirrors that and see how well chat systems work in these type of environments, as opposed to, here's a perfect sentence, a perfect breakdown of what I need, which oftentimes and rarely times happen, and usually end users are pretty upset if they have to do that.
And I guess it sounds like, I almost imagine mapping the original data, like limited data that people have, in an embedding space. And you kind of want to like find samples that are related to it, so it's like cosine similarity style, but that's not enough. You also want things around this space that's like slightly out of distribution but still domain specific, so that you can kind of capture a holistic sense of how the application might be used in real life. And then build like the data set synthetically, and LLMs are good for that, but it's not as easy as just prompting them one shot and trying to get like hundreds of samples out. It requires a lot of thought on getting the distribution right.
That's right. That's exactly right. It's how do you find questions that are similar to the questions you want to see, but different enough to add a lot more predictability into the models. And then the other thing, it's not just prompting, because you're spot on. A lot of times the type of errors we need to introduce are kind of categorizable, which is like, was this error wrong because it hallucinated? That's the easiest one. Next is it wrong because it's vague, right? So one question I like to say is, if you can ask an LLM, right? Let's say I said, how old am I? And it said, you're, 34 years old, 32 years old. Is that right? Most people say, yeah, that's right. But then I can argue, but it didn't say the months, right? Like 32 and 4 months or 5 months. And you're like, okay, let's get more specific, right? And that degree of specificity is where it gets a little bit tricky in understanding what is correct and what's not correct. And if it's vague, is it misleading? And defining those is so tricky. And one part of our strong suit is we understand there's vagueness, which is why we've introduced fine tuning. But that makes it really tricky as well. So vagueness is another one. Misleading is another one. There's a lot of different categories of it. Omission of data, relevance, So it could be completely right, but not even close to like relevant to what the actual question was. Omission of data is like, it's right, but it doesn't actually, say anything, and it's relevant. So it's like, how old are you? And it's like, well, I am pretty old. It's like, okay, that's great, but like that's
didn't actually
didn't answer
my
anything.
question.
Yeah. That's not it's
Yeah.
relevant. It has stuff, but it's not great.
And that's subjective too. Like it
Very
depends on
subjective.
how the developer wants their application to behave, and there's like it's almost like a slider of thresholds.
That's
for,
right.
I want this to be relevant enough, or I want this to be vague enough,
Yeah.
or omit enough, or like you kind of decide what's acceptable
Yeah.
performance to you.
That's right. And if you're super precise, you get into this weird area of why don't you just give them the doc?
Oh yeah,
Which is like, it's the RAG without the generation, so it's just search. It's like, why do we even need the generation part? Let's just give them the data, which is, there's no chance of hallucination because it's the original
it's the
data.
original source of truth. Yeah.
But then the question is, all the benefits of the human computer interaction is lost, and people love that.
Yeah.
That's why ChatGPT got so popular. And so how do you reintroduce that?
So you've talked about like generating the data synthetically,
Yep.
and now you kind of mentioned a little bit ago about labels, and we know like nobody likes testing and nobody likes labels like that. Labeling is such a painful process.
Yeah.
And so first, I guess, can you automate that? And second is how do you kind of entice people to label?
Oh, okay. Food. No. Yeah. So if you buy them food, they'll label. It's a good question. Is it fully automatable? Not fully. Based off of our interactions, there's still some human judgment that needs to be there. Now, can you basically 10x the productivity of people who are able to provide labels? Yes, with LLMs and other machine learning techniques, but it's quite difficult to get it to fully automation, like full automation, and no one needs to provide it. One thing we found quite often is, although it's labeling, there is, especially for those in the ML world, a little bit of a stigma, because generally the way that labeling was perceived back in the day was you just get a bunch of people and they'll take a very simplistic task that requires human judgment and we'll scale it up, which is
an army of people, basically, like
cat not cat, dog not dog.
Yeah.
Put a square on like, is this a car or not? It's almost like the Google.
Yeah.
The Google.
Bounding boxes and.
What do you call it? The bot detection.
Yeah.
It's getting hard, but like it's very similar to those type of tasks. And
it
I
trips
think,
me up sometimes.
Yeah,
I'm like, am I human?
Yeah, I don't know if you tried LinkedIn's one. They're getting tricky.
Yeah.
Balance the ball while you rotate the captcha to get it to point north, and so you gotta bring a compass in. So it's. I think there's a certain amount of stigma against it, and because of that, it has a negative connotation. But the labeling nowadays, it's almost like you need subject matter experts.
Yeah.
You need someone who has a really strong compass on what's right and wrong. And able to use that as a North Star for where to align the data and the models. And so no longer is it the days of just get anybody. Can you tell if that's a cat?
Yeah.
You're on. It's like cat, not cat. Now it really does require subject matter experts. Talk to a lot of modeling companies and the ones that are providing foundation models, and they're talking about, in order to get better data, we're hiring editors, publishers, people who can just process tons of text data.
Experts and like leaders of their field.
Yeah. Because that's the only way to get it. And it almost reminds me of the days of back in the day, Google used to have a model for detecting skin cancer from x-rays. And in order to collect labels, they need to pay hundreds of thousands of dollars to doctors to label it for training. And it's kind of falling into that category where the higher quality data you get from experts, the better these models get. Yeah.
That's fascinating. But I guess at least what we've seen from customers is not every enterprise is gonna need an army of labelers. It's usually like a team that's building an AI application, and they still need to do some labeling, but oftentimes they're not even sure where to start or what can be automatable, what can be human, what requires human input. So how do you walk them through that? How do we walk through our customers through that process?
Yeah. So first it's getting the first data set, taking a look at the data set. One thing that happens far too often is you get only the data set with positive labels.
Yeah.
And that's really unfortunate because if you train a model or anything with that, it will say everything is good.
Is great.
And it's 100%. And so you do need to do some label balancing. So we get the data set and we take a look at it. And from there, we kind of get a sense of what are the types of errors that they're seeing or they might be seeing from here. With our intuition already from there, what we can do is take that data set and then start amplifying it, which is let's start taking this data set and creating negative samples from it for common ways that these are going to be error prone. Let the LLM do a little bit of creativity, but do the original categorization of types of error so that the LLM could be much more focused.
So basically prompt the LLM in the right way to generate
induce the right error.
I see.
Yeah. And then once we have that, it's augmenting it further, right? So at that point, we're at roughly 40 to 50 data points. We want to get in the range of a few hundred.
Yeah.
Then if we have the original corpus of data or the context that's passed in, what we can do is pass that and the question, and then you mentioned the embedding space, find similar ways of saying questions but different enough, use that to, with the context, to produce more correct question answer pairs.
Yeah.
And once you produce more question answer pairs that are correct, we can then do the inducing of errors again. And now we're looking at somewhere between a few hundred to 1,000.
Yeah.
And we've shown that this process is quite effective in using the domain or out of domain knowledge of how questions are structured and how to produce errors within these questions to then map it to the domain and still have a lot of predictive power on doing testing. And then at that point, once we have the few hundred to 1,000, we're able to use that both for testing, and we always make sure that some of the testing data is the original data because that's really important to make sure it doesn't drift.
That's the highest quality things that you want
Exactly.
to validate. Yeah.
And then we will fine tune an evaluator, and we can use that for creating a fine tuned metric for you that you really care about. And so you're starting to see a lot of similarities with how foundational model training is going. We're seeing a lot of similarities with, enterprise grade RAG systems and enterprise grade agentic systems, that a lot of the processing power and the infrastructure plus models is what's making high quality applications that are used today.
Which is pretty magical. Like, we may start with like maybe a dozen or like very small amount of sample data and are able to like expand that to a much larger set.
That's right.
Which is almost like, first there's kind of like test case generation, you know, because you could use that as test cases, but then also you can sample some of that as a training set for training the evaluator model.
Exactly.
And then that represents kind of like your evaluation criteria.
Exactly.
And then I think like there's more sophisticated stuff perhaps on, sorting by entropy or other kind of like things on how you prioritize which things need a human to take a look at and which things can be fully automatable.
That's right.
So any like parting thoughts on that front? Like, how you said not fully when I asked like how much can a human do and how much can be fully automated. Like, I guess paint us a picture for the percentage split that people should expect.
Yeah, really good question. I almost feel like it's a 90 to 10 split, maybe 95 to 5 being what a person will need to do, and then 95 being what the LLMs can do. Just as you were talking, it kind of struck me that the testing feels similar to generating unit tests for code,
Right.
where if you pass in the function and you say, build me a good unit test, it's generally quite good.
Yeah.
Because the full context is there for what you want to.
And you can look at code coverage and all sorts of like
Exactly.
things to analyze it.
The actual questions coming in are much more free form.
Yeah.
Right? There's not a sense of correctness that code will have. But using the right heuristics, using the right ways of how these modeling components come together, you can do quite well.
No.
And so we're building a lot of that, and that's been really useful for unblocking people to get better testing within their enterprise applications. Yeah.
Amazing. And I just love that, ultimately it all comes back to data and having good data, doing good data science.
Yeah.
I think sometimes like in the hype that exists around LLMs, we forget that it's still, data science, and everything starts and ends with data.
Exactly. It all starts and ends with data, and not clean data.
Yeah.
It's a very
messy
very
data.
messy data.
Increasingly messy data.
Yeah. Increasingly, getting messier as people are
Yeah.
getting more comfortable, and so I think fun challenges ahead, but it's exciting on what we're working on.
Absolutely.
Cool.
Thank you for all your input on this.
Thank you. Have fun at the Lego store.
Enjoy the play.